Hi, I hope you're fine. This is Monisha. Today's topic is about structure from motion. Structure from motion is a multi-view stereo. Assumes it's a camera calibrator. We have both extrinsic and intrinsic that are well known for all the views. How do we compute calibration if we don't have to know it? In general, this is called a structure from motion. There are two views solved from a fundamental matrix or the essential matrix. We can factorize into an intrinsic, rotation, or translation. What about more than two views? If it has more than two views, the geometry of the three views is described by 3 cross 3 cross 3 tensor called a trifocal tensor, and 3 cross 3 cross 3 cross 3 tensor called a quadrifocal tensor. After that, it starts to get complicated. Instead, we explicitly solve the camera poses and geometry scenes. First, structure from motion, we have given many images. How can we figure out where they were all taken from? We can build a 3D model of the scene. This is roughly the structure from motion problem. Structure from motion, it has an input of image with points in correspondence, that P of I comma j is equal to U of I comma j comma V of I comma j, and in output it has both structure and motion. In structure it has a three-dimensional location xi for each point pi, and in motion the camera parameter rj tj, possibly kj. So the objective function is minimizing the reprojection error. As doubled from the video, we have seen was two-dimensional translation, effects, etc. Relation between two-dimensional and the images. Now we are explicitly representing 3D geometry of camera and points. In this, we have the inputs, we have detecting the features, and we are matching with the features. In camera calibration triangulation, suppose we know 3D points and we have matches between these points and an image. So how can we compute the camera parameters? Suppose we have know the camera parameters, each of which will observe a point. Then how can we compute the three-dimensional location of that point? Structure from motion solves both of these problems at once. A kind of chicken and egg problem, but it's a solvable one. This is a phototourism, how to get corresponding feature detection and matching. So the detected features with Si of t. Here the match features between each pair of images. We will refine matching using RANSAC to estimate the fundamental matrix between each pair. The image connectivity graph produced by using a graphics toolkit. Correspondence estimation. It is like a pairwise matches to form a connected components of match across several images. Then, as previously, this input, feature detection and feature mapping. So, listen, for all the ends it have, nearly for this it have 7. You have 7. Then you have mapped for problem size in the structure from motion. We have to define what are the variables and how many variables per camera and how many variables per point. In triform 10 collection, we have 466 input images and plus greater than 1 lakh 3D points. Very large optimization problem. So we are using structure from motion, like minimizing some of the squared reprojection error. This equation shows you this minimizing this function is called a bundle adjustment, optimized using nonlinear least squares. That is the example for this. Its structure from motion is always uniquely solvable? No. Then incremental structure from motions, only these two has been incremented. For Photo Explorer, these are the possible outcomes. It shows you how the globe will be. sorry, how the moon will be. This is the possibilities of moon, SMF application, 3D modeling, structuring, robot navigation and map, visual and augmented reality, visual effects. In application, we have